Good day, thanks for joining us. In this lesson, we want to look at three things. Very simple, but set the appropriate foundation for your further work in chemistry. We want to look at chemical formulae, the writing of a chemical formula. We want to look at balancing equations, and then we want to look at the calculation of the RMM, the relative molecular mass. So stay with me for a little while. Let's look at writing a chemical formula. Let's take, for instance, calcium hydroxide. Calcium hydroxide. Calcium is a +2 ion. Calcium is a +2 ion. The hydroxide ion is -1. Now, in writing the chemical formula, simple trick, we cross multiply. The number here, 1, we place here. The number 2, we place here. All right? Now, we then look to relate the numbers like this, which will give us calcium, 1 calcium, hydroxide, 2. Hydroxide, 2, brackets, 2. That's calcium hydroxide. Let me repeat. The charge on the calcium ion is +2. The charge on the hydroxide ion is -1. We cross multiply. Calcium 2, hydroxide 1. It means, therefore, we will have 1 calcium and 2 hydroxides. Therefore, calcium hydroxide. Now, we can go further and look at some others. Let's look at calcium sulfate, for instance. Calcium sulfate. Now, it is important over time to learn the names of the anions and the cations with their relative charges. Calcium +2, sulfate -2. Again, the rule, we cross multiply. 2, 2. Now, whenever I see the numbers being the same, I reduce it to 1, 1, 1, 1. And so therefore, we will have 1 calcium and 1 sulfate. Calcium sulfate, therefore, is CaSO4. Now, once we get an idea of the charges on the ions, we know the charges on the ions, we're able to cross multiply, and then we interchange the numbers. Again, calcium sulfate, calcium is +2, sulfate is -2. We cross, this number 2 comes here, this number 2 comes here. The numbers are the same, so I have 1 to 1. I have 1 calcium to 1 sulfate. 1 calcium to 1 sulfate. Calcium sulfate, CaSO4. Let's try another. Let's look at aluminum sulfate. Aluminum sulfate. Aluminum is Al +3, and as I said, over time you'll want to learn the charges on your cations and anions. Aluminum sulfate. The rule, cross. Number 2 comes here. What number comes here? 3. We link the numbers. So therefore, we'll have 2 aluminums and 3 sulfates. 2 aluminums and 3 sulfates. Now, how would this look? aluminum, and 3 sulfates. Now remember, to show 3, we must include the bracket. Let's look at it again. Aluminum sulfate. Aluminum is +3, sulfate is -2. Rule cross. The number 3 comes here, the number 2 comes here. We link the numbers, 2 and 3. I have 2 aluminums and 3 sulfates. 2 aluminums and 3 sulfates. Al2SO43. Now, whenever we have an anion looking like this, which is more or less complex, we put brackets to show the number of the anions. In this case, 3 sulfate anions. All right? Aluminum sulfate. Let's try another. Let's look at magnesium chloride. Magnesium chloride. Magnesium +2, chloride -1. Rule cross. 1, number 2. Link the numbers. I have 1 magnesium with 2 chlorides. 1 magnesium with 2 chlorides. I write Mg, it's 1, followed by 2 chlorides, Cl2. Now, I don't need to put brackets here because chlorine is Cl. 2 chlorides with 1 magnesium. Magnesium chloride is MgCl2. Now, as I said, it is important to know the names of the cations and the anions with their respective charges. That must be learnt. That will not be provided for you on an exam. You must know your cations as well as your anions, and then you follow this procedure of drawing the cross, interchange the numbers, and then you link them. All right? Let's look for another one. Sodium phosphate. Sodium phosphate. Sodium, Ne plus, phosphate, sodium phosphate. Cross. Number 3, number 1. Link the numbers. Ne3 PO4 once. Ne3 PO4 once. Now notice, I don't need to put brackets here. Why? Because we have only 1 phosphate and iron. And so therefore, Ne3 PO4. Let's repeat. Sodium phosphate. Sodium, a +1 iron. Phosphate, PO4 -3. I cross. Number 3 comes here. Number 1 comes here. I interchange my numbers. Na3 PO4 once. Sodium phosphate. All right. Now, the way to get this going is by further practice. So I'm encouraging you, learn your table of cations and anions. Repeat this exercise. Look for other examples, work them through so that you'll be able to write the chemical formulae. All right. We want to look now at what is called the RMM. The RMM. Simple, but we still want to cover it because it is required. RMM. RMM, or the relative molecular mass. Relative molecular mass. Let's look. Example. I'm sure you know this is water, H2O. In calculating the relative molecular mass, we realize we have 2 atoms of hydrogen and 1 atom of oxygen. Now, on any exam, the masses are normally provided for you, the atomic masses. Over time, as you practice your chemistry, you would learn, it will be etched in your minds, the atomic masses of various elements. Okay? Now, I'm not asking you to trust your memory, but it is good to have it stored so that when there is the opportunity to do your calculations, it's easy to recall. But over time, as I said, that will become part of your practice. Other than that, it is placed normally on your examination paper. Now, water, 2 atoms of hydrogen and 1 atom of oxygen. Hydrogen weighs 1. I have 2 times 1. Oxygen weighs 16. I have only 16 because it is 1 oxygen. 2 hydrogens, 1 oxygen. 2 plus 16 equals 18. 18 grams. So the relative molecular mass of water is 18. Let's look at another one. Let's look at hydrogen peroxide. I have 2 atoms of hydrogen and I have 2 atoms of oxygen. 2 atoms of hydrogen, 2 atoms of oxygen. 2 times 1 equals 2. 2 times 16 equals 32. Answer? Of course, 34 grams. 34 grams. Now, let's continue with some other examples. Relative molecular mass. Now, as I said, this is fairly simple, basic mathematics, but I'm going through it because it is necessary. When you go to calculate, do mole calculations, for instance, you will find this absolutely necessary. Let's look at this. Calculate the RMM. I have 1 carbon, I have 4 hydrogens. 1 carbon, carbon weighs 12. Hydrogen, as you know, weighs 1. I have 4 hydrogens. 12 plus 4 equals 16 grams. 16 grams. Let's look at another example. Calcium sulfate. I have 1 calcium. Calcium weighs 40. I have 1 sulfur. 1 calcium, 1 sulfur. Sulfur weighs 32. I have 4 oxygens. Oxygen weighs 16. Calcium weighs 40. I have 1. Sulfur weighs 32. I have 1. Oxygen weighs 16. I have 4. All right? So that gives me 40 plus 32 plus 64. When I add this up, 64 and 32, 96, and 40, 136 grams. 136 grams. We could continue with some further examples, but as I said, the way to have this is by practice. Keep practicing your RMM. So let's look at this. C8H18. 8 carbons, 18 hydrogens. 8 carbons, 18 hydrogens. So carbon weighs 12, but I have 8 of them. Hydrogen weighs 1, I have 18 of them. 8 12s, 96, plus 18. 114 grams. That's your RMM, relative molecular mass. Now, what we've done initially was to look at the writing of a chemical formula. Now we have looked at calculating the RMM, the relative molecular mass. I want to move a little further and look at balancing equations. Now, that too is fairly simple, but a lot of students have difficulty in balancing an equation. Let's look at how this could be done. I trust that it will be helpful to you. Let's look on. Balancing equations. Balancing equations. Now, let's start with something simple. Carbon plus oxygen forms carbon dioxide. Now, I should include my state symbols. Now, in balancing equation, I need to look at everything I have on my left and ensure that it is the same on my right. Whatever is on my left must also be on my right, hence balanced. I have one carbon here. I have one carbon here. Fair? I have two oxygens here. I have two oxygens here. Now let me repeat. This 2 here is not for carbon. This 2 is for oxygen. So I have one carbon, one is understood here, one is understood here. So I have one carbon, two oxygens, two oxygens. So that one is balanced. Now, let's look at this one. Carbon plus oxygen, now forming carbon monoxide. I have one carbon. That's okay. I have two oxygens. I have one oxygen. So something is off with the oxygen, so I need to balance. Now, I could put a 2 here, but that will be changing the equation. Carbon monoxide is formed, CO. I have to maintain CO. If I look, I have two oxygens here. So I think the trick would be, let's try this. Put a 2 here. Put a 2 here, right? Now look at this. If I put a 2 here, I have 2 carbons and 2 oxygens. 2 carbons and 2 oxygens. I have 1 carbon here. Put a 2 here. Let's see. So I end up with 2 carbons, 2 carbons, 2 oxygens, 2 oxygens. Repeat. I have 2 carbons, 2 carbons, 2 oxygens, 2 oxygens. All right? Now, let's continue with another example. Let's look at CH4 plus O2 all right? Now, I have 1 carbon. I have 1 carbon. But I have 4 hydrogens. And I have 2 hydrogens. Now, if I have 2 hydrogens there, let's try 2. Put a 2 here. Now I have 2 2's. 2 2's are 4. Now I have 4 hydrogens, which will be equivalent to this here. Now let's look for oxygen. How much oxygen do I have? I have 2 oxygens here, and I have 2 times 1. This 2 refers to all of this. So while I have 4 hydrogens, I'll be having 2 oxygens. 2 times 1 would be equal to 2. So I have 2 oxygens plus 2 oxygens, which give me 4 oxygens. I have 2 here. Let's put 2 here. 2 2s are 4. Let's check again to see if it is correct. I have 1 carbon, 1 carbon. Carbon balanced. I have 4 hydrogens. I have 4 hydrogens. I have 4 oxygens. 4 oxygens. 2 oxygens plus 2 oxygens give me 4. Balanced. Now, let's look at something else. Let's look at this. Sodium hydroxide plus hydrochloric acid forms sodium chloride and water. Okay? Let's look. I have 1 sodium, 1 sodium. That's pretty straightforward balance. I have 1 chloride, 1 chloride. Balanced. All right. I have 1 hydrogen plus another hydrogen. 1 plus 1, 2 hydrogens. Okay there? And I have 1 oxygen. Look at here. Is it balanced? Well, yes, it is. Okay? Now, looking at another example. Sodium hydroxide plus sulfuric acid forming sodium sulfate and water. Okay? Now let's see. I have 1 sodium here, but I have 2 sodiums here. Alright, so let's try. Let's put a 2 here. 2 times 1 will give me 2, which will be equivalent to this. Alright? Now, I have 1 sulfate, SO4. Now, it is not 4 sulfates, it is 1 sulfate. SO4 is the anion. I have 1 sulfate. When I look here, I also have 1 sulfate. Now, let's see. I have 2 hydrogens here. 2 hydrogens. Looking here, I have how many hydrogens? 2 ones. I have 2 hydrogens also. And I also have 2 oxygens. 2 times 1 equals 2. 2 times 1 equals 2. In total, how many hydrogens do I have? 2 plus 2 gives me 4 hydrogens. Let's put 2 here. 2 2s. 2 times 2, 4. Which will be 2 hydrogens plus 2 hydrogens giving me 4 hydrogens. I have 2 oxygens. 2 oxygens. All right? Let's try another one. Now, if you go from the simple equations to the more difficult ones, and you have the idea or the principle of how to balance an equation, it is very much the same. So you start with a simple one, you see how to do it. You practice the simple ones, and you apply the same information from solving a balance equation in its simplest form Apply the same to the more difficult ones and it works. Let's see. C4H8 plus O2 forming CO2 plus H2O. Alright? Now I have 4 carbons. I have 4 carbons. Now let's see. If I have 4 carbons here, let me try 4 here. Okay? Alright, I have 8 hydrogens. How many hydrogens do I have here? I have 2. If I put 4 here, I will now have how many? I will have 8. Now let's cover again. 4 carbons, 8 hydrogens, 4 times 2, 8 hydrogens. Now let's see how many oxygens we have. I have 4 oxygens there. Correct? 4 oxygens there. How many oxygens here? 8 oxygens. 8 oxygens. In total, I will have 12 oxygens. 12. How many do I have here? I have 2. I'll put a 6. 6 times 2, 12. 6 times 2, 12. Now, let us see if this makes sense. Let's go over it. 4 carbons, 4 carbons. 8 hydrogens. 4 twos, 8 hydrogens. Oxygens, 6 times 2, 12 oxygens. 4 times 2, 8 oxygens. 4 times 1, 4. 8 plus 4, 12. So as I said, you look at the very simple ones, you practice, apply what you have learned from the simple ones to the more difficult ones, and the same thing works. So in this lesson, we've covered 1, how to write a chemical formula. That is, you look at your cations and ions, you draw the cross, you record the numbers, you then interchange the numbers, and you have your chemical formula. Then we looked at the relative molecular mass, also called the RMM. Write out the formula. You'll have a sheet giving you the atomic masses. You assign the atomic masses to the atoms in the formula. You multiply as the case might be, and then you add. And then we've also looked at balancing equations, ensuring whatever is on the left is also on the right, playing around with some numbers from the very simple ones to the ones that are more difficult. As I said before, the way to get through this, chemical formulae, RMM, and balancing equations, come through practice, and yes, even more practice. Just take a look at this, consider it again. You may want to write it for future reference as you engage further study. Thank you so much for viewing. Would you share this if it has been helpful to you? Send it to a friend, share with a friend or a class member. Thank you so much. Until next time.